Lead and the Clean Air Act. Let's talk about it. All right, so lead is a fairly abundant element in the Earth's crust. It's a heavy metal that's toxic at pretty much any level. Like they keep revising it over the course of the last century, and every time they examine it, they go, you know what? There's no level that's really safe. But here's the thing: it's not normally part of the atmosphere. Sometimes you can get contaminated into groundwater, to soil. It's usually not part of an atmosphere. But that all changed in 1920, and here's why. So gasoline engines were becoming quite popular. People wanted cars, and one problem they had with cars is that the power stroke of a car's cylinder is supposed to come when you have maximum compression of the gas. That's when you want to ignite it. You don't want to ignite it until it's all the way up at the very top, and then boom, it pushes it. Okay, so that's the idea behind how an internal combustion engine is supposed to work with gasoline. Unfortunately, here's what often happens. Here, so I can show you this. Okay, so you get what's called a pre-burn. So what happens is sometimes gasoline, as it's being compressed, it ignites before it's supposed to, and when that happens, you get this sort of knocking sound. See, it basically stops. You reduce the power, and it's damaging the car, and it greatly reduces the power you get from your gasoline. And most gasoline is a mixture of thousands of different kinds of molecules. Many of them are 8 carbon chains, 7 carbon chains. But the thing is, most of them tend to ignite too soon. So they came up with a solution. Beginning in the 1920s, oil companies began adding a substance called tetraethyl lead. This is what it looks like here. So it's got 4 ethyls stuck to it. Okay. And these break off pretty easily. And it just turns out that by putting this into gasoline in fairly small amounts, it completely reduced that pre-ignition component of it and made the gasoline act in a much more efficient way. Unfortunately, the lead that's in here would go out the exhaust pipes into the air. Now the companies that invented this said, "Look, it's just a small amount. We're just putting a little bit in there. It's not a big deal. It's not going to hurt anybody." Okay. Of course, at that time we didn't really understand its toxicity. Still, wasn't a great idea. And what happened was in the 1920s, not that many people drove cars. In the 1930s, after the 1940s, this is the United States. People came back from World War II, the country industrialized, and all of a sudden everybody's driving cars. So you look at that change in the amount of lead going to the atmosphere was staggering. So, as I said, there's no level that isn't harmful to humans, and it causes lots of different things. Okay, there's lots of problems it can cause. It can cause hypertension, which is high blood pressure. It can cause heart problems. It can cause cancer. But one of the saddest of the things it can cause is neurologic impairments, especially of developing children. So, when children are exposed to lead, it disrupts the ability of their brain to form the correct neurological connections. And just look at this graph here. So, they've done many studies, like so many studies like this. So you take blood samples and you analyze it for blood. And here's what you find: that the as the amount of lead in children's blood increases, their IQ levels drop, and it's this very clear trend. So in other words, having lead in your system as you're a developing child is definitely going to cause significant intellectual impairments that are going to last you through the rest of your life. And we'll revisit this later on. Now, just to say, I mean, it's kind of a mean thing for me to say, but let's just talk about this guy, Thomas Midgley Jr. Okay, Thomas Midgley Jr. was a chemical engineer who worked for Esso Oil Company, and he's the first guy who said, "Hey, look, there's this stuff called tetraethyl lead. We've done the experiments, and it definitely fixes this knocking problem we have of pre-ignition." So he pushed this idea, and it got accepted by the oil companies and became sort of standard across all the different oil companies. He later went on and invented a substance called Freon, which was the first widely available CFC, chlorofluorocarbon, which, as we'll talk about later in the year, if you don't already know, was responsible for almost completely destroying the ozone layer. So you have this like one man walking ecological catastrophe. And the thing is, he died before he even knew how much harm he had done. But anyway, there you are, Mr. Midgley. Way to go. Way to destroy the environment all on your own. Anyway, let's go on. So here's some good news. And this is something we should all take a good look at. It's a good model for what other countries should engage in. In 1970, the United States passed the Clean Air Act. And there was a lot of pollution at the time. They said, look, we're going to fix this, okay? So it's considered by many organizations to be one of the most important, comprehensive legislations ever passed in order to rein in pollution. And it really worked. If you go to the United States, you'll notice the air in the United States is actually much better than this in most parts of the world, and it's because of this Clean Air Act. All right, so what did it do? Okay, first of all, it established these what we call ambient air quality standards, or NAAQSs. In other words, it said, like, this is how much of these pollutants there ought to be in the air. So these are the ones we've been talking about, like sulfur oxides, carbon monoxide, nitrogen oxides, volatile organic compounds, ozone, PM, especially 2.5, and lead. Okay. Now notice we didn't talk about lead the other day because it's really not a problem anymore, thanks to the Clean Air Act, at least for starting it. Now, the other thing it did is the Clean Air Act is it set standards for this is the allowable amount of these substances that can be in the air. And if you pass that, something's going to happen. Well, what's going to happen? Well, they also established a thing called the EPA, the Environmental Protection Agency, that put some teeth into this legislation. So you basically made this bureaucratic organization whose job it was to do the research, to set these standards, to monitor to make sure they're being met, and if they're not met, to enforce them being met and to punish the people who are polluting. It's a great model that the rest of the world should embrace. And by the way, it's also something you're supposed to know about on the AP test. There's a few environmental legislations you need to know. If there's one you definitely need to know, it's the Clean Air Act. Now let's look at this. Beginning in 1973, so the EPA is only 3 years old, not even that, like 2.5 years old. They said, okay, look, we're going to deal with this lead problem. All right, so they said we're going to start phasing out leaded gasoline and switching to something else. Turns out, if you notice, most gasolines today use ethanol. Well, guess what ethanol does? It reduces that knocking problem. Okay, so so look at what happened. The amount of lead in the atmosphere went screaming upwards, and then in the 1970 we passed the Clean Air Act. By 1973, they said, "Okay, we're going to do away with it," and boom, it came screaming down. In the course of my lifetime, lead levels went from here. This is when I was basically starting middle school. It's kind of scary. Down to here, right? We fixed that problem, right? Okay. So yay EPA. It's a great job. Now let's just look at what happened by taking lead out of the atmosphere. It's pretty remarkable. So first of all, look at this. So this is the circles represent lead in this amount of lead being used in cars, and here's the amount of lead present in people's blood. Both things are being monitored, and look at it. It's a total correlation. Of course, if you're breathing in lead, it's going to get into your bloodstream. Okay. Well, what does that mean? Well, there's lots of different ways we could look at this. Okay. It's a little bit difficult to tell, like heart attacks, because there's lots of things that can cause that. Cancer, there's lots of things that cause that. But there's a few things we could look at that are very clearly related to lead. One of them that might surprise you, though, is this. Look at this correlation. Atmospheric lead levels are closely correlated to violent crimes. So if you look, the level of violent crimes and the level of leads rose together and then dropped together, at least until here. And then people just got more violent as the lead levels dropped. But you might think, like, okay, well, maybe that's an accidental correlation. Maybe there's no causality here. And maybe there's not, because it's difficult to say exactly what causes behaviors like violent crimes. However, look at this. Here's 4 more countries they've done the study with. Okay, here we got New Zealand. Lead goes up, violent crime goes up. Here's Great Britain. Lead goes up, violent crime goes up. Lead goes down, violent crime goes down. Same thing in Australia. Same thing in Canada. So there's not a known reason why this is, but the correlation is very clear. Lead causes problems, and one of them makes sense. It causes neurologic problems, and that could cause emotional problems that could lead to people engaging in violent crime. Another one we can look at is just high school dropouts. That's a rate that's easily recordable. And here you have in the 1920s and 30s, very few people dropped out. As lead levels go up, the rates of dropping out go up. And as the rates of lead go down, the rates of people dropping out of high school go down. Again, that doesn't prove that there is a causality here, but the correlation is pretty striking. All right. So anyway, that's it. I just want you to understand that lead used to be a huge problem, and by the way, it's all countries starting like last year. Actually, this year, I think it was finally this year that Algiers was the last country to say we're done with leaded gasoline. So there's no more leaded gasoline anywhere on the planet, and that's a good thing for the planet. It's a really great thing for children and their developing brains. Hey, thanks for watching.